Okay, in this example, we're asked to find the domain of the function, let's see, the square root of x plus 2 on the top, and then x plus 4 outside of the square root sign on the bottom, and to answer in interval form. Now, it's going to be a patchwork quilt kind of a thing here because I was having some technical problems with my pen, so we'll just fill in the blanks. What we need is for the top, the radicand upstairs, to respect the rule that it has to be greater than or equal to 0. But we also have to make sure that the bottom is never equal to 0. This one's complicated. Let's see. The word "and" means intersection. So we're going to consider the intersection of these two requirements. We're going to find all the x values that respect the radicand x plus 2 being greater than or equal to 0 and the bottom x plus 4 not being equal to 0. To respect both of these conditions, we have to graph the solution for each of them and then take the intersection of the two. So first, let's stack some number lines and take the intersection. The first condition will be represented in the first number line. The condition is the radicand needs to be greater than or equal to 0. So x plus 2 has to be greater than or equal to 0, which means if we move the 2 over to the other side to isolate the x has to be greater than or equal to negative 2. We can graph that. And then, let's see, it's a boxy bracket at negative 2 and then shading to the right, everything greater than or equal to negative 2. Now, the second condition is that the denominator cannot equal 0, so x plus 4 cannot equal 0. Move forward to the other side, we have x cannot be equal to negative 4. So we're going to graph everything on the second number line except negative 4. So we're including everything except negative 4. And then you take the intersection of these two shaded regions, and remember, the intersection means everything in the first set that also exists simultaneously in the second set. So only values of x that live simultaneously on the first number line shading and the second number line shading. So if you look at the region to the left of negative 4, there's only shading included for the second restriction, x not equal to negative 4. In the middle, there's only shading included for the second condition, x is not equal to negative 4. But on the right side, to the right of negative 2, we include those x values in both the first condition, x greater than or equal to negative 2, and the second condition, x not equal to negative 4. That means only those x values to the right of negative 2 will be included in the intersection. Okay, so shade that region to the right of negative 2. Now let's think about negative 2. Will that be included? Well, it's certainly included in the first inequality because there's a boxy bracket on negative 2. It's actually included in the second inequality because the shading passes right through negative 2. Therefore, negative 2, x equals negative 2, exists in both the first and the second inequality, which means it simultaneously lives in both sets. That puts it in the intersection. So include it in the intersection with a boxy bracket on negative 2. Now write your answer. This is the domain, the picture of the domain. The domain of the function f in interval form is boxy bracket, everything from negative 2 to infinity with a round bracket at the end.